Okay, I need you to take your journals out if you've not already done so, because we are going to do a concept map that is going to review chemical naming. You may want to turn your paper horizontal, but we're going to kind of put all of the rules on one page. Okay, so we're going to review chemical naming. Now, before we do that, I want to remind us of the periodic table and all the things that it can help us do. I'm really only going to focus on the top part. We're not really going to name much down here in the F block. So we're going to mostly focus up here. And the first thing I need you to draw your attention to is the stair-step line. Okay, the big thing on the stair-step line is that everything to the left of the stair-step line is going to be considered a metal. Everything to the right is going to be considered a non-metal. Now, I know I'm lying to you because we had some of these metalloids, but for the purposes of naming, that's the big differentiation that you need to remember. The only exception is that hydrogen is also going to be a non-metal. Okay, so you need to keep that straight first, because that's going to be how we're going to differentiate. Alright, so first thing, therefore, is when we're naming, we need to look at two things. Are there only two atoms in the compound, or are there more than two atoms in the compound? Okay, we're going to focus on the two atom ones. These are typically referred to as binary. Bi means two, only two atoms. If both of those two atoms are non-metals, okay, non-metals, so they're both going to be over here or hydrogen. Alright, so carbon and oxygen, fluorine and chlorine, any of those. They are going to be covalently bonded, and these are the ones where you're going to use the prefixes. This is the only time that you are going to use the prefixes: mono, di, tri, tetra, penta, etc. Okay, there's a couple of ions that have prefixes built into them, so I'm lying to you just a little bit, but this is the only time you're going to have to put prefixes into your compounds. So for example, if you have, let's do N2O5, remember the rules are if there's more than one on the first one, it needs a prefix. So this would be dinitrogen pentoxide. Remember, we dropped the A, so it would be pentoxide, as opposed to CO2, which would be just carbon dioxide. That first one only needs a prefix if there's more than one. Okay, so that is two atoms that are both nonmetals. Now, if we have one nonmetal and one metal, okay, so if we have one from over here, one from over here, that is going to be a scenario, where we have an ionic compound. Okay, now with ionic compounds, there are no prefixes. No dis, no tris, no tetras, whatever. Because it's going to be implied, because we always need the charges to equal 0. So the only curveball that really comes in with ionic compounds is if you need a Roman numeral for the D blocks. And the only time you need a Roman numeral for the D block is when they have more than one option. What I mean by that is if you look at the periodic table, some of these that are going to be, let's pick a different color here, alright, over here in the transition metals, right? Transition metals, and even up over until where you get over to the metalloids, some of these suckers in here can have more than one ion. Okay, we'll have more than one ion, and it shows that on your ion sheet. For example, here's your monoatomic side. So anything that has a Roman numeral means there's more than one option. So copper 1 is going to be a 1 plus. Copper 2 is going to be a 2 plus. Excuse me. You have several different options. The only ones that do not, the only ones that do not have a Roman numeral in there are going to be, let's come back here, let's pick a different color here. The only ones that don't are zinc, whoa, not quite what I was looking to do, but that's alright, zinc, cadmium, and silver. Okay, those are the only three that only have one option and don't have a Roman numeral, which you can notice because silver does not have a Roman numeral, cadmium does not have a Roman numeral, and it's probably down the bottom here, zinc does not have a Roman numeral. Okay, and it'll take a while to get there, but those are the patterns we need to recover with. Okay, so anyway, if there's a Roman numeral, then you have to incorporate that. So for example, some options here. Let's do some not D blocks. Well, if I have some not D blocks and I have a sodium ion and a chloride ion, to write the formula I crisscross them, or I need the whole thing equal to 0, so the formula here would be NaCl, as opposed to if I had a combination of the magnesium ion and the bromide ion, I need the whole thing to equal 0. So I'm going to need 2 of those negatively charged bromides to cancel out, or if you do the crisscross, since this is a 1 here, that becomes the subscript for the magnesium, so I need 1 magnesium and 2 bromides. Okay? Now, again, where the Roman numeral piece comes in here is that for a combination of copper and bromide, I can have 2 options. Okay, and this is how I would know which one it was. If I had CuBr2, I'd have to uncrisscross it. Well, the fact that I have 2 bromides tells me that copper has to be copper 2, and bromide is always going to be a 1 minus. Okay? And this one would be copper 2. Why is it copper 2? Because I'm dealing with a copper 2 ion, bromide, or another option again that I could have would be CuBr. Well, if I crisscross those, bromide is always a 1 minus, copper is always a 1 plus. This is copper 1 bromide. Okay, again, that 1 plus tells me that it has to be the copper 1 ion. So just a few things, you know, that 1 and 2 tells me which copper ion I'm dealing with. Okay, now I know I'm kind of just giving you the brief overview here. It'll take practice, and that's just the way it's going to be. Now, the other option is if you have more than 2 atoms. This is going to involve a situation where you use one of the polyatomic ions. Okay, polyatomic ions are found on this sheet right here. They are separated into 2 groups. Ions you need to memorize for quizzes and exams. Okay, you will not have access to these on the Unit 6 test as well as the final exam. And then ones that are not as common that will always be provided for you. Okay, and essentially what these guys are a combination of atoms that when they settle together they have a charge. So for example, the ammonium ion is 1 nitrogen and 4 hydrogens that when they're covalently bonded together, overall they have a 1 plus charge. So we can use them to also name compounds. So again, since we're dealing with ions, we have no prefixes. Okay, we're still going to have no prefixes here. So you'll notice, now there are some, this is where I wanted to point out, we don't add any prefixes in. There are a couple that have prefixes already in there, just to point them out. For example, bicarbonate, okay, already has the bi prefix in there. So you leave it, you just don't add any new ones in. The other one that always throws people down here is dichromate. Okay, the reason the dichromate is in there is because there's 2 chromiums for this particular substance, but those are really the only times that you see prefixes on there, and it always throws people just a little bit. All right, so no prefixes. Again, the only curveball is, do you need a Roman numeral for one of your D blocks? Okay, so let's just do a couple of samples of those really quick. For example, if I had, let me separate it out here just a little bit. Let's say I had K2CO3. Okay, well right away I've got more than 2 atoms, so we know it has to at least be 1 polyatomic ion. Okay, so I find I've got carbonate, and my formula here is going to be potassium carbonate. Okay, the reason I knew that there had to be 2 potassium ions is if I were to uncrisscross it or write the charges, carbonate has a 2 minus, and I needed 2 potassium 1 pluses to get those to balance out. Alright, now on the flip side, let's say we had iron 3 phosphate. Okay, well, and honestly, my suggestion to most of you is when you're first going from a name to a formula to take the time to actually write out the ions. So how do I know it's iron 3? Well, that Roman numeral automatically tells me that is the charge. Anytime you look at the D blocks, the transition metals, okay, you'll notice the copper, all of these are all 1 pluses. Well, they're in the 1 plus column. All of these guys down here have 2 pluses. They're in the 2 plus column. 3 pluses, etc., etc. Okay, so all the 3 Roman numerals are in the 3 plus column. So there are some patterns to it. Okay, phosphate. If I find it on my polyatomic ion sheet, it's going to be PO4 3-. So when I crisscross these, it's going to be, they're going to cancel out. So it's going to be Fe PO4. Now let's say I had iron 2 instead of iron 3. Well, if I had iron 2, I would have Fe2+, F phosphate. This formula would instead be Fe3, because I need 3 of those guys, and I need 2 of the entire phosphate. Okay, I know it's tricky. You're going to do some practice. We'll get to review it again, but just want to again point out some options. One other thing I want to point out is, remember, the periodic table can also help you with the charges of the main group elements. For example, everything in a group 1 has a 1 valence electron. Well, all of these guys will always form a 1+ ion. The group 2s always have 2 valence electrons, so everything here will form a 2+ ion. And you see that on your ion sheet. All of these right here and the 2+s are all group 2 alkaline earth metals. Okay, notice I put that on there up there. Your group 1 are your alkalis. Oops. Group 1s are your alkalis. Group 2s are your alkaline earths. On the flip side, when we come over on the other end, your group 17s are all the halogens. Well, every single one of those guys has 7 valence electrons. So they want 1 more to be happy. So if they have 7 valence electrons, these guys will form 1-. These guys have 6 valence electrons. They want 2 more to be happy. They'll form 2-. These guys will form 3-. Okay, so again, using that periodic table can help you. Good luck. I hope that was helpful. And